Geometry students, in this lesson we are going to be talking about another form of triangle congruence known as side angle side congruence. So previously we learned that if three sides of a triangle are congruent to three sides of another triangle, doesn't matter what the orientation of those triangles are in space, those two triangles are congruent to each other because their three sides are congruent. In this lesson we're going to learn that it just actually takes two sides and an angle to prove that triangles are congruent. So we could do it with three sides, but we could also do it with two sides and one specific angle of the triangle. That angle is actually going to be called an included angle. What is an included angle? An included angle is an angle shared by two adjacent sides of any polygon. So we're not necessarily just talking about triangles when we talk about the included angle. If I pull over here a couple of triangles for us to look at, I can identify that of side BC and side AC, the included angle would be the angle shared by those two sides, angle C. Same thing down here, angle FE and DE shares included angle E. So that's the definition of an included angle. That's going to be really important for our side angle side congruence because the included angle is the angle that has to be congruent to prove that the triangles are congruent. Now I'm just going to mention something that's not as important for side angle side congruence generally, but applies in some problems. There is such a thing as an included side. Now the sides in side angle side do not have to be included sides. It doesn't make sense for them to be. An included side is a common side shared by two consecutive angles of a polygon. So if I look at angle DFE and angle FED, I notice that there's an included side FE. But that's not really helpful in side angle side congruence. Here's where it's helpful, okay? I'm going to drag this set of triangles over. Now, I want you to think about this. Do we have two sides and an included angle that's congruent in this set of triangles? And the answer is yes. Now, most of the time we're used to seeing, like up here, side marked once, side marked with two little hash marks, and then if these angle B and E are congruent, because those are the included angles, then I can say that these are congruent by side angle side congruence. Down here I've got an angle that's marked here and an angle marked here as congruent to each other. And I have this side, but I don't have a second side that's clearly marked as congruent. Okay, so what's going on here? Well, these two triangles have an included side. This angle here and this angle here share this side. And if two triangles have an included side, that included side is automatically congruent. And we'll talk about why in just a little bit. But because this side is shared, I know it has to be the same for both triangles. And that's why included sides are important. Every once in a while we will run into a problem with SAS Congruence that uses an included side, and you can assume that the included side is congruent in both triangles. All right, now what is our postulate? Our actual postulate, postulate 15, is the side angle side postulate. If two sides and included angle of one triangle are congruent to two sides and included angle of another triangle, then the triangles are congruent by side angle side congruence. We're going to see in just a moment our proof for this is going to be proving that one side is congruent, proving that another side is congruent, and then proving that the included angle is congruent. Once we prove all three of those things, then we can say the triangles are congruent by side angle side congruence. All right, I'm just going to drag these guys back off to the side, and let's get to the problem set for this lesson. We're going to work some practice problems. Determine whether the pair of triangles is congruent by the side angle side postulate. So I'm going to ask myself, do these two triangles have a common side? Yes. Another common side? Yes, here and here. And then is the included angle between those two sides marked as congruent? Yes, so therefore these two are congruent by side angle side. Next we need to find the value of x that makes these triangles congruent. How would you go about doing it? Okay, let's see. Well, this is pointing to this angle here. This is pointing to this angle here. Notice that that's the included angle between the two known sides. So we're not saying that these triangles are definitely congruent. What we're doing is finding the value of x that makes them congruent. And what value of x would that be? Well, I have to set this up as an equation. 3x minus 12 equals, the included angle would have to be equal for them to be congruent, 2x plus 8. Okay, now I'm going to subtract 2x from both sides. That's going to give me 1x on the left minus 12 equals 8. Now I'm going to add 12 to both sides. That's going to give me x equals 20, and that's how we got our answer. All right, now, the more important one. Let's look at letter C. Use the side angle side postulate to prove that triangle WXY is congruent to WZY if WZ is congruent to WX, that's that little tick mark on the side there, and ZWY is congruent to XWY. That's the angle marker at the top. Okay, do I really truly have side angle side congruence here? Well, I should probably make a 2-column proof to prove that these two are congruent. First thing I'm going to do is make a 2-column proof that has statements and reasons. Now, this one's going to be really simple because my statements include almost everything that I need just from the givens. What am I given in this problem? I know that segment WZ is congruent to segment WX. I just know that from the drawing, but I also know that from what it says is true in the problem. I also know that angle ZWY equals angle XWY. So those are congruent angles. I said they were equal. Really, that's sort of the same thing, but we're making congruent statements here, so it's important that we state that the corresponding sides of the triangles and the corresponding angle are congruent. Okay, what are the reasons for this? Well, those are the givens. Now, I have two sides that are congruent and an angle that's congruent. All I need to do is prove that the other side, the side that's part of the included angle for both of these is congruent. And actually, this really works out well because this is one of those included sides. With an included side, there's something that I can always state. That side is congruent to itself. And I need to state it with side angle side congruence because I do need to prove that all three sides, the two sides in the included angle are congruent. And I will state that based on the reflexive property of congruence. Any geometric figure is congruent to itself. All right, and then lastly, I can just, now that I have two segments and their included angle being congruent to each other, I could say that those two sides of the triangle and that included angle cause the whole triangle to be congruent to the other triangle. So I can just state that WXZ is congruent to WYX. I can only do that after I've stated that two sides and the included angle are congruent, and then I can state that by postulate 15, side angle side congruence. All right, we'll get to D in the next video. This one's going to be a bit longer of a proof, but it's a good one, so stay tuned.